Hello and welcome to our new unit. We're going into quadrilaterals. So this is our first lesson in it. It's going to be on polygons and interior and exterior angles and how we kind of navigate how many degrees are in each polygon, how you could navigate pretty much any polygon, the sum of interior angles and exterior angles. So without further ado, hopefully you already got that title down in your table of contents. Go ahead, rewrite it here, and let's get started. So a polygon is pretty much just a shape with three or more sides. And it goes from triangle to quadrilateral to pentagon, etc., etc. And there's actually a nice kind of convenient formula for it, and hopefully catch on to it just based off of this. So let's start off with, for instance, let's just make a table. Number of sides. So we're going to actually do this. We're going to actually split this right down the middle because we're going to actually have a lot of different polygons that we're going to talk about. And oops, I probably should move this over a little bit more. Number of sides along with its name. So that's a separate column. And then last but not least, this is going to be in pink. You don't have to copy this down, but it'd be nice to know sum of interior angles. So what that means is like a triangle we know has 180 degrees. We also know, for instance, that there are three sides. Ooh, that should be in, there you go. And we call this a triangle. Any three-sided shape is called a triangle. Now, a four-sided shape is always called a quadrilateral. Okay? And that is not 180 degrees, but 360 degrees, just like a square or a rectangle. Keep moving. We have a five-sided shape. A five-sided shape is called a pentagon, penta meaning five. And here is the appearance of that gon name. So just like any polygon. Pentagon. Okay. Six-sided shape would be called a hexagon. So hexa meaning six. A seven-sided shape has two names. I'll accept both of them if we ever come across it. Heptagon or septagon. An eight-sided shape, you should know, octagon. And then a nine-sided shape, a little bit unfamiliar. It's called a nonagon. So non for nine. Moving over to the other side, we're going to repeat this. We're going to copy this over. Copy. So it's going to be the same thing. Now we're going to go into a 10-sided shape. A 10-sided shape is a decagon, just like decade. 11-sided shape, we're actually going to skip because we're going to go to 12. A 12-sided shape is what we call a dodecagon, do meaning two, and then decagon, as we just talked about, meaning 10. So 2 and 10 make 12. We're going to skip 13 and 14. We're going to go straight to 15. A 15 is a combination of pentagon and decagon, what we call a pentadecagon. Okay? And then we go to pretty much like any sided shape, N. We call this an n-gon. So an example of this would be, for instance, a 20-sided shape will literally just be called a 20-gon. Now, how do you find the sum of interior angles for a 20-gon? Well, it follows a very, very specific formula. You take the number of sides, and we should probably do this in color. So I'm going to put a star next to this because this is one you'll need to know. N minus 2, the number of sides minus 2, times 180. 180 for 180 degrees. So for instance, if you take a triangle has 3 sides. 3 minus 2 times 180 would be 1 times 180, and you get 180 degrees. Okay? Now you could also do this for a quadrilateral. Quadrilateral has 4 sides. So we do 4 minus 2, which is 2, times 180, which makes it 360. We see that happen here. Okay? And that pattern repeats itself over and over. In other words, you actually just keep adding increments of 180 from shape to shape. So this would actually be 540 degrees. Hexagon would be 720. Then a heptagon would be 900 degrees. The octagon would be 1080 degrees. Nonagon is 1260. Decagon would be 1440. Dodecagon, and we could keep going and going, but you use this formula, number of sides, to solve for the rest. So I'm not going to make you do that. I put this in the wrong spot. Sorry. Number of sides minus 2 times 180. And this is used as the sum of interior angles for any n-gon, or polygon, really. Okay. Now this might be something worth putting in your notes. Ooh, I probably should cut this off just a little bit because we didn't use all this space, and let's not waste it. So this might be worth putting in your notes. What's a convex polygon versus a concave? Convex polygon versus concave just means this. In a convex polygon, let's say it's a pentagon, all of the sides, all interior angles are less than 180 degrees. Versus a concave polygon, you get some kind of weird shape sometimes. So you could have something like this, where you have an interior angle or angles, I'm going to put that in parentheses, which are greater than 180. So you get that weird concavity with it. And that's why we get that weird kind of shape. So it might be worth noting. So if you want to put that in the notes, go for it. We don't talk about it very, very often, but on the off chance that we do talk about it, you now know what it is. Now, here's an interesting thing. If you have, for instance, a triangle, we know a triangle has 180 degrees on the interior. What about the exterior? The exterior, is, as we talked about, is the angles on the outside. And you have angles all around. Now, if you, for instance, think of this as a equiangular, that means all the angles are 60 degrees on the inside, which means on the exterior we have 120 to make the full supplementary or linear pair. We would have 120 degrees here and 120 degrees here. So what is the sum of exterior angles? Well, if you add all of these up, this is equal to 360. And if you actually do this for, let's say, a square or even a rectangle, well, if you do the exterior angles, you get another 90 degrees, another 90 degrees, another 90, another 90, which makes 90 times 4, 360. Is this a coincidence? Absolutely not. Because you could actually repeat this over and over and over again with any shape, whether it's pentagon or a 20gon, and you should realize that all of the exterior angles, the sum of the exterior angles, will always be equal to 360 degrees. So this is an important feature about pentagons, is that the sum, that looks terrible, the sum of exterior angles, exterior angles is always going to be equal to 360 degrees. Okay? So this is worth noting. We should also know what regular means. A regular polygon. A regular polygon is a polygon whose angles, interior and exterior, I should say, angles are all congruent, meaning this is a little deceiving. All interior angles are congruent and all exterior angles are congruent to each other. So all interior angles would be the same. So this is what this means. All interior angles are congruent. All exterior angles are congruent to each other. So what I mean by that is kind of like like we just talked about. We had a triangle. A triangle is technically an equilateral triangle or equiangular triangle. All the angles are congruent, making them all 60. All the exterior angles turn out to be 120 degrees, as we talked about. And you could actually repeat that over and over and over for every pretty much pentagon, hexagon, etc., etc. So if you do, for instance, a quick example of it. If we did, let's do a hexagon. We know that the hexagon has 6 sides, which means that since there's 720 degrees, and you need to take that and divide by 6. 720 divided by 6 sides, or 6 angles, gives you 120. That means all of these are 120 degrees, if this is regular. Okay, but what does that mean about the exterior angles? Well, we know that they are supplementary because they make a linear pair. So there should be 60 degrees on the outsides of all of these. Okay. And as you see, 60 times 6 is 360 degrees. So it fits the criteria of the sum of exterior angles is 360 degrees. You get that idea. Now, there's a really, really nice, easy way to do that is, well, if we did if we did 6 times, if we repeated this, right, you would take the sum of interior angles equation. Sum of interior angles is equal to 6 minus 2 times 180, which would be equal to 720 degrees. So that's the sum of the interior angles. So it's kind of like step 1. And then step 2 would be to do exactly what I did here. Take the sum of interior angles, divide by the number of sides or angles. Okay, so I'm going to actually change this from 720 to the sum of interior angles. So no matter what it is, whether it's a pentadecagon or if it's a decagon, sum of interior angles divided by the number of sides will equal one interior angle of a regular polygon. Okay. Then, last but not least, what if you want to just solve for regular one exterior angle? So I'm going to do that as a separate one. Let's do, for instance, one exterior angle of a regular polygon. Well, the nice part about it is that we know that the sum of exterior angles is always going to be equal to 360. And we know that there are always, that many number of sides. So we could actually solve for that really, really quickly by taking this 360 degrees divided by the number of sides. So for instance, if we did this hexagon, we would take 360. So if we did this for a hexagon, 360 divided by 6 sides, and that would be equal to 60 degrees. So that means one exterior angle for a regular hexagon is equal to 60 degrees. Okay? So there's a lot. I understand there's a lot of information here, especially all the names. I would definitely get these at the very least done, or at least those, and then know this equation. And then a lot of it kind of just stems from that because you build off of that. Everything that I talked about right here builds off of that number of sides minus 2 times 180, and knowing the definition of what regular is. This is a nice bonus. We should know that as well. Okay? If you do have any questions, please let me know, and I will see you in the next